Hello students, welcome to the course Analysis and Design of Algorithms. In this course, we are now at Module 2, where we'll be learning about some design techniques for creating solutions for various real-world problems. Among those design techniques, one very important design technique is the divide and conquer. As I talk about this particular technique, I'll scroll down through your learning management system so that you can see where all the content has been uploaded. Now, for the module 2, which is for divide and conquer, for the next session, we'll be discussing very much in detail about a technique called as recursion. Now, recursion is the basic foundation for the divide and conquer technique. Now, for the next class, rather than being a very traditional class where I teach and you hear and then go home and practice, we'll try a very different technique. What we'll try to do is, I'll give you all the content beforehand. And you have to go through all this content while you're at home and then come to the class, where in the class we'll have a lot of time to practice so that your higher order thinking skills are enhanced and we have ample of time to discuss the issues that you have with these concepts. So for that reason, I've put up all the content required for this particular topic right on your learning management system, and here it is. So first go through this particular link, Introduction to Recursion. I've opened that link in another tab for you here in the demonstration. Now, once we complete this entire recursion concept, the objectives for this particular session are the student should be able to understand the concept of recursion and be able to differentiate between recursive and non-recursive solutions. Non-recursive solutions are sometimes called as iterative solutions. So you should be in a position to differentiate which is a recursive solution, which is a non-recursive solution. You should also be in a position, you should also have a competency to apply the concept of recursion to computational problems. Not just that, you should also be in a position to analyze how an activation stack in the memory is used for modular programming. The reason why we talk about modular programming here is because recursion is all about dividing your program into modules and then trying to call the same module again and again. So with this concept of modular programming, we need to analyze how the activation stack is actually being utilized in the computer. So these are the three main objectives with which we'll discuss this particular topic. So by the end of it, you're going to crack all the three objectives. Now let's go further. Now I've given you few readings and few videos to go through at home before you come into a session, right? So here are the links for it. I set them as pre-class talks. So pre-class, so you need to do it before you actually come into the class. So here are three readings. The first reading is about understanding the basics of recursion. The second reading is about understanding the difference between recursion and iteration, especially in terms of execution of the programs. And the third one is about reading on practical applications of recursion. Now, all the three readings were taken from RMIT University, Melbourne, Australia. Now, just mere reading of documents is not sufficient. What I want you to do is, I want you to go through some videos by a very popular person, Professor Eric Grimson from MIT, who has taken up this course, Algorithms, at MIT, which is available for us through MIT OpenCourseWare. So I've put up two videos. The first video is a general video on recursion and dictionaries. So that is an introductory video. Once you go through the introductory video, you have another video called as Towers of Hanoi. Now, this particular video is what I want you to focus more on for the upcoming session. Now, once you click on this video, you will be taken to a link which looks like this. So let's have a quick glance at Professor Eric.
We've seen recursion. We've seen this idea of breaking problems down into simpler version of problems. But at this stage, you may be looking at it and going, oh, come on, the examples you're showing, they're easy to solve in an iterative fashion. What's the big deal here? So I want to show you an example of a problem that is beautifully captured by thinking recursively and really hard to do if you're going to try and think iteratively, to give you the power of that recursive thinking. And the problem is an historical one, or a classical one, called the Towers of Hanoi.
So, Professor Eric will be discussing about one practical application of recursion, which is the Towers of Hanoi. So I want you to go through this video. Now this video is an interactive video. What do I mean by an interactive video? As you progress through this video, you cannot actually scroll it forward unless you watch it, right? There's the catch. And now, once you're done with this video, look at this little circle here. So that means at any given point of time, you will be asked some questions. There are around 4 questions which you need to answer in order to progress further in this video. So with these interactive content, I can understand that you have gone through the video and you have answered the questions and you have the confidence that you understood the concept before you come into the class. So once you watch these 2 videos, I want you to take a small quiz which has got just about 10 questions. So take up this quiz so that you and I are clear about your understanding of the concepts. You can go wrong, absolutely no problem. You can take up multiple attempts till you get the right answer, which is also perfectly fine. But then I want you to take up this quiz before you come into the class so that I know where you stand, basing on which I can design my active learning methods more efficiently, right? Now, just a quiz is not sufficient. You might have a lot of questions after you have taken the quiz, after you have gone through the videos. So what I did was I created a discussion forum for you to discuss about the non-tail recursive programs. Once you go through the readings, you'll understand what a non-tail recursive programs are. So go through what a non-tail recursive programs are and start discussing about non-tail recursive programs, their advantages, their drawbacks, and how do we convert them into iterative programs. Does a compiler do that automatically? Doesn't it do it automatically? You should be discussing that with various examples. Now, this is a graded discussion. That means you also get to review one of your peers, one of your friends' discussion. You can add some examples to it, or you can discuss on the example that they have already quoted. You can only review their discussion after you post your example into the discussion forum. So once after you do, you read these readings, the documents, and then you go through the videos, take up a quiz, and then participate in a discussion forum, you are perfectly ready to be in the class and start taking up an activity. See, before you come into the class, you already have every information that is required for you to participate in active learning in the class. Now, once you're in the class, I already gave you a gist of what is the in-class activity going to be. I'll divide you into pairs. The classroom structure, the way you sit for the pairs, is already given to you here. Sorry, this is the link. Yeah, so the seating arrangement is already given to you here. So based on your serial numbers, you sit according to this before we start the class. And then there is some piece of code for you to quickly go through. As you go through this piece of code, you're supposed to fill in these details. So this is something that we'll do in the class. But before you come into the class, all that I want you to keep in mind is make sure you go through the documents, go through the videos, take the quiz, both in the video and off the video, and participate in the graded discussion forum. And then when you come into the class, sit according to the seating arrangement that is given to you. Now, with all this being done, I'm hoping for a fantastic active learning in the class where you're all very active, participating and contributing to each other and to the class about what recursions are. Thank you.